Hello guys, I'm a teacher Ulimboka Sajigo Masame. Welcome to Ulimboka Physics. I have a question below that states that an optical fiber has an index of refraction N and diameter D. It is surrounded by vacuum. Light is sent into a fiber along its axis as shown below. Part A. Find the smallest outside radius R minimum permitted for a bend in the fiber if not light is to escape. Part B. What result does part A predict as D approaches 0? Is this behavior reasonable? As n approaches 1 for part D, and part E evaluates R minimum assuming the fiber diameter is 100 micrometer and its index of refraction is 1.4. Okay, consider this diagram below that we use to modify from these original diagrams and arrive into conclusions. Okay, from modification for these given diagrams from the book, we have diameter D, and this is R, radius of this curved optical fiber, and this is assumed to be a complete circle with a radius r. Then from drawing here diagrams, and this is usual diameter of this optical fiber, and this is center of the circle of this curved optical fiber, and this is its radius. And here is light that enters through this part as drawn here, and we take the light that enters through part M straight to part O, this incident light, and then this light undergo total internal refractions after a condition of critical angle reached and incidence exceeded its critical angle. Then the R is equal to 90 degrees, that is OQ, and the internal refractions continue inside this optical fiber. Okay, and we have this triangle OC and M. Let us use this triangle MOC and triangle POQ, so that we can find the relationship between R and this R minus D. This is D, and this is MC is R minus D, and this is incidence angle. Okay, now from Snell's law of refractions, N for plastic, N for air, sine for incidence and sine for refracted is equal to constant. N for air is equal to 1, and sine for refracted is equal to 90 degrees as shown there, and sine for incidence is equal to MC opposite divided by hypotenuse, which is OC. Then we substitute MC, which is R minus D, and OC is our radius R, which is equal to 1. Then our refractive index for plastic is, as you can see here below, this is equations 1. And R minimum, then we cross multiplication so that we make the subjective for R, and then R minimum is, we can see here below as equation number 2. For a part B, we have asked what result does part A predict as D approaches 0? As this D approaches 0, then the optical fibers we come from the equation of sine, the sine which is equal to R minus D divided by R. When we take D is equal to 0, then our sine of incidence is equal to 1. Then our sine inverse is equal to 90 degrees. Therefore, at any light that enters through this optical fiber, the total internal reflections will occur. At any bending, we say that at any bending, it will allow the total internal reflection, and is almost this optical fiber is equal. Is straight line, because this R minimum here is approaches 0. R minimum is approaches 0 from this relation, because this D is 0, and therefore the expression here will be R minimum is equal to 0. Therefore it will be elongated optical fiber, straight optical fiber, that will allow a bending of light or internal reflection for any light that enters through it. Okay, for part C, we ask okay, as n increases and n increases, the result does part A predict. Okay, this is already part C, and is also this behavior reasonable. This behavior is reasonable because we have a straight optical fiber. Not all optical fiber are allowed to bend or curve. Okay, and n increases. If n increases, before we reach part B. If n increases, we know that if n increases from these expressions, n increases is this one increases, R minimum is approach equal to D. R minimum is approach equal to D, because this one and this one will cancel out. R minimum is approach equal to D. And also remember, this D is always small, the R minimum will be very small, and hence our optical fiber will have a very small curve, will bend very little. Okay, because this is okay. And then for part D, as n approaches 1, our R minimum will be equal to infinity. Therefore, if our R minimum is equal to infinity, now our sine incidence will be equal to 90 degrees. Now our incidence angle will be equal to 90 degrees. Therefore, the condition for critical angle is now satisfied here. Our R will be equal to critical angle. Therefore, for any bending, even is at infinity, the light will undergo total internal reflection within the optical fiber. This is the same as this part B. Okay, for part E, we are asked to find the R minimum, to evaluate the R minimum when we have given the diameter, all of diameters there. Okay, from given data, as we can see here, and then from our expression number 2, then we substitute the value, the refractive index of the plastic, then we will have R minimum as 350 times 10 to the power negative 6 meter, and this in micrometer is 350 micrometer. Thank you for watching. Please like, share, comment. Don't forget to subscribe to this YouTube channel for more video like this one. Thank you.